Now for the solution for the Haxxed challenge. Now it says here, you've been rooted, sad face, interfere with communications from the hacker to the command and control resource. Our second hit is fingerprinting might help slightly. Now you can see here that one is worth 40 points, the other one is worth 100, so obviously one's probably going to be easy and one's probably going to be really hard. When we pull this up, it looks like a bad late 1990s defacement page. And if we look at our request being made, we can see that some communication is going on here. The first request made to command and control says, "Hello, I need to talk to you now." The response is some hash. That hash is then being sent to the Haxxed, which responds back with some transform on it, which goes back to the command and control, comes back with another hash. So basically these two are communicating here through you. So you can imagine that it's a Haxxed that has rooted you and then is using you to make communication to the command and control server, which then comes back to you, which then goes back to the Haxxed. So essentially, being rooted is really like man in the middle by design, if you realize it. Now the first hint was interfere with communications to the CNC resource. Well, here's a request to it. If we just send it again, it says old message encountered aborting. So let's send a different message. Let's just change the value by 1. Okay, we've essentially interfered with communications now. So there's the first flag. Congrats on learning how to man in the middle, whether you intended to or not. Sending the CNC server its own private key will cause it to self-destruct. Now, again, going back to the hints, I say fingerprinting might help slightly. And if you were to fingerprint this, some of the things that you would do is obviously look at what's powering the application, what technologies are underlying it, what kind of info leaks are being revealed, like in the headers. You might also check cross-domain.xml and robots.txt. Robots.txt happens to disallow a hint location, and if you were able to solve top secret beta, there's also, and that also tells you to check hint.txt. So a hacker has rooted you and is tunneling secure communications through you to his command and control server. The CNC server needs you to send its response, which then gets forwarded back to the hacker, leaving no trace of his communication to the CNC server. So here we've given you the code for how the actual encryption is happening. And what you need to do here is do a bitwise XOR on the response coming back along with the hash, and then from that you can basically reverse engineer the key. So let's look through our history again. If you take the message that is being sent to the Haxxed, and the response coming back, and just kind of look at it to try to make sense of what's going on. One of the first things that I would notice from this is that numbers are coming back as something that's consistently very low on the ASCII table, and letters are coming back very high. So something is being done per bit on each of these. 0 comes back as 05, which is a non-printable character, that's why it's URL encoded. C comes back as 56, so a letter's in the 50s. 1, 4, and 8 are numbers, so 02, 04, 0C, which in hex is A is 11, B is 12, C is 13, etc., etc. So we need to do a bitwise XOR on each of these characters against each other to reverse that back to the key. Now I wrote a solution in Python for this. This is a solution that would be much faster solved by scripting. And I'll walk you through what goes on in my particular solution, but there's many ways you can solve this. So the first thing that I'm going to do is take every character in this hash and convert it to decimal values. So on the ASCII table, if you just Google for an ASCII table, we can see that 0 is 48. Same thing here. 0 is 48. C is 99, so lowercase c, 99. But doing this one character at a time by looking at this table is going to take a lot of time. That's why it's much better to use a little bit of coding prowess to just make these transforms real quick. So we do that for each character of this. Now the same thing with each of these, because it's like %05 is a non-printable character. Those are going to need to be converted as well to decimal. So from 05 is 5, 56 is 86, 2 is 2, 4 is 4, etc., etc. Because right now these are in hex. When you XOR those together, the first from each one, so 48 XOR 5 will give us the first character of the key. 99 XOR 86 will give us the second character of the key. So here's 48 XOR 5, 99 XOR 86, etc., going all the way down. 53, 53, 51, 48, 52, 53. Now these just need to be converted back into characters. 53 is 5. Again, the ASCII table will show you all of this. If we look at 53, here's 53 in decimal. The character for it is 5. 53, 5, 53, 5. 51 is 3. 48 is 0. Put those all together, and now we have a key. Copy that. So sending the command and control server its own key will self-destruct it, right? So let's send it its own key. And there we go. Self-destruct activated. Yay! And we have a flag.